Machine learning has become the backbone of many modern technologies and predictions, from weather forecasting to financial market analysis, healthcare insights, and much more. Today, I'm going to show you how machine learning can be used to simulate and analyze an election prediction, focusing on the 2027 election scenario. Now, it's very important to clarify this up front. The data we'll be using in this video is fully simulated. This helps us avoid legal, ethical, and political issues while still demonstrating how the technology works. If you're interested in working with real-world data, I've shared a link in the description where you can get suitable data sets and feed them into the same model to run your own experiments. The goal of this video is not to influence opinions, but to educate and demonstrate how machine learning models analyze patterns, probabilities, and trends. To do this safely, we'll use ChatGPT to generate custom simulated data. We won't be reading out the numbers directly. Instead, we'll focus on the important fields like region past Party A and Party B vote shares, voter turnout rate, youth and urban population percentages, unemployment and inflation rates, GDP growth, incumbent party, simulated winner for 2027. Using this data, we'll train a machine learning model to estimate probabilities and visualize potential outcomes. Once we've saved our simulated dataset as synthetic_data.csv, the next step is to install the Python libraries we'll need. We'll be using NumPy for fast mathematical operations and handling arrays, Pandas to load, organize, and manipulate our data in tables, scikit-learn for building and training our machine learning model, Matplotlib to create graphs and visualize results. You can install them all at once using pip:. Now that we have our libraries installed, let's import everything we need for our project. Here's a quick breakdown of what each part does. Pandas as PD for reading and managing our CSV data in tables. NumPy as NP for fast numerical calculations. Matplotlib.pyplot as PLT to create charts and visualize our predictions. Train test, chsplit, splits our data into training and testing sets so we can evaluate the model fairly. Random forest classifier, a powerful machine learning model that can handle complex patterns. Logistic regression, a simpler model, great for estimating probabilities of outcomes. Standard scaler, normalizes our data so the model can learn efficiently. Pipeline, helps us combine scaling and modeling into a single step. Accuracy score, tells us how well our model predicts compared to the actual outcomes. With these imports, we're ready to load our data and start building the prediction model. First, we'll load our simulated dataset using Pandas. When we run df.head, it prints the first 5 rows of our data, which gives us a quick look at what's inside. For example, it will show something like this: region, past Party A vote share, past Party B vote share, voter turnout rate, youth population percent, urban population percent, and their respective data. Now that we've loaded and inspected our data, the next step is to choose which features we want the model to use for predicting the election outcome. Here's what each feature represents: past Party A vote share and past Party B vote share. How much support each party had in previous elections. Voter turnout rate, percentage of people who voted. Youth population percent, proportion of young voters in the region. Urban population percent, how urbanized the area is. Unemployment rate and inflation rate, economic indicators that can influence voter behavior. GDP growth rate, economic growth of the region. Incumbent party, which party currently holds power. These features give our machine learning model the context it needs to estimate probabilities for each party winning in 2027. Before we train our model, we need to split our dataset into training and testing sets. This helps us see how well our model can predict new, unseen data. Here's what this line does. X contains all the features we just selected. Y is the target column. In our case, winner 2027. Test size equals 0.25 means 25% of the data will be used for testing and 75% for training. Random state equals 42 ensures that the split is reproducible, so you or anyone else running the code will get the same result. By doing this, we can train the model on one set of data and evaluate it on another to check how accurate it is. Now it's time to train our machine learning models. We'll use two models: Logistic Regression, a simple model that estimates probabilities; Random Forest, a stronger, more complex model that often gives better predictions. Here's what's happening. Logistic Regression pipeline. We first scale the features so that all numbers are on the same range, which helps the model learn better. Random Forest. This model creates multiple decision trees and averages their predictions. That's why it's usually more accurate. Training. Both models learn patterns from the training data. Evaluation. We then check how well they predict the test set using accuracy, which tells us the percentage of correct predictions. After running this, you'll see something like model accuracy, synthetic data; logistic regression, 0.80; random forest, 0.92. This tells us that on our synthetic data set, the random forest is slightly more accurate than logistic regression, which is expected for small but complex datasets. Here we have a line chart showing the estimated number of votes per county for Party A and Party B. On the x-axis, we have the counties, and on the y-axis, the estimated votes each party might get according to our machine learning model. The blue line represents Party A, while the orange line shows Party B. You can see how the support varies across different regions. For example, in Nairobi and Kiambu, Party A has significantly higher estimated votes compared to Party B, indicating strong support in those areas. On the other hand, counties like Kisumu and Nakuru show Party B leading in estimated votes. This visualization helps us quickly identify which regions are stronger for each party and where the competition is closer. Keep in mind, these numbers are synthetic and only meant to demonstrate how machine learning can estimate probabilities and trends based on features like past votes, population, and economic indicators. Notice also the peaks and dips in each line. They reflect how factors such as urbanization, youth population, and voter turnout might influence the number of votes in each county. In short, this chart gives a clear visual snapshot of potential voting patterns across the country, helping us see at a glance which regions are likely to favor one party over the other. Here we have a bar chart showing the overall winning probabilities for Party A and Party B, based on our synthetic data. Party A has a 53% probability of winning, while Party B sits at 47%. This chart gives a high-level view of which party is slightly more likely to win according to our model. Remember, this is simulated data, so it's just a demonstration of how machine learning can estimate outcomes using historical patterns and regional factors. The chart is a simple way to summarize all the county-level estimates into one overall probability, making it easier to interpret at a glance.